So you're standing on 2 feet. You're exerting force on the floor. If you lift 1 foot, we have established that this does not change the amount of force you're exerting, does it? Okay. But something changes, right?
Your balance.
Well, your balance definitely changes. You can support yourself with a finger on the desk if you need to. Okay, now I'm going to have you step it up a notch. Go up on tiptoe.
1 tiptoe.
1 tiptoe. What? Little tiny tiptoe.
I can't.
Okay, are you changing the amount of force that you're exerting on the floor?
No.
What are you changing?
Where it's in its position.
Well, how much area you're spreading that force out over?
Very
Yes.
direct. Dog bounce on your Mickey did.
Yeah. So,
I got it.
that is pressure. You are putting a lot more pressure on the floor than you were when you were standing with 2 feet. Because when you're standing with 2 feet, all the force that you're exerting downward is spread out over your 2 feet. When you go up on tiptoe on 1 foot, you've just concentrated all that force into a little tiny spot. So this is why they don't allow high heels on gym floors. Because in a high heel, you're concentrating a lot of the weight of a human being down in a little tiny square, like a centimeter by a centimeter square, and that will do damage to a floor. Flat gym shoes, no problem. Okay? So that's pressure. Pressure is just the amount of force divided by the area over which it's spread. Okay, you can all sit down now. So, I need to ask you a question.
Okay.
Do you feel like you're under pressure right now?
No pressure.
Dun 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 dun. Yeah. Okay. You don't feel like you're under pressure right now? Christian, do you feel the weight of the world crushing you, pushing you down into the surface of the planet, as though there are tens of thousands of feet of gases pushing down on your head?
Always.
Really, you feel this, Thomas. You feel this. You feel the weight of miles of gas pushing on your head. Now, that's normal. Because you, in fact, do have miles of gases pushing down on your little head.
Oh,
I'm so sorry.
Bro.
I'm sorry. It's the atmosphere. Welcome to planet Earth. It's okay. Your physiology will handle it. Your bones, your muscles, your sinews, your tendons are all very well adapted to withstand atmospheric pressure.
So it's kind of like a whale, like people.
Yes, it is very much like that. And if we took you to the surface of Jupiter and deposited you on the surface of Jupiter, where the atmosphere, you would implode. You would turn into a little pancake, a squishy, bloody pancake. It would be rather disgusting, but it would be over really fast.
Why are you so
where would you explode?
You wouldn't. Oh, where would you explode? Space.
Where'd you like?
In the vacuum of space with no spacesuit, all of you would just fly apart. Your solid material would boil.
Oh, so you get like.
You would turn into a gas.
So how did we
Anyway, so pressure. When you are at sea level, when you are at sea level, which we're about 1,000 feet above sea level here. We're not much above sea level. There are about 10 newtons of force on every square centimeter of your body. So draw a square centimeter on your notes, please. I want to see if you can figure out what a square. I just want to see if you have some approximation of roughly what a square centimeter is. After you've drawn it,
That seems to be about us.
okay, once you've drawn it, I'll give you a ruler. You can tell how big you are.
That looks like
Draw a square centimeter.
That's your square.
That's a cube, Anna.
Oh, yeah.
Oh, good use of gauging. I like it.
That is 1/2 of 1 centimeter.
Well,
Wait, so just a line or actually?
How about half? Oh, okay.
I got a half one. Did you get a half?
Okay, how good are you?
what
So,
is a square?
1 Newton is about the amount of force. Well, let's see. 1 Newton's about the amount of force that it takes to
I got
lift
centimeters.
a small apple. Good.
So
The atmosphere is pushing on your head every little square centimeter of your body with the force of like 10 apples. 10 average-sized apples. It's an incredible amount of pressure that you're under. It's crazy. You're under pressure all the time from the atmosphere. We can measure atmospheric pressure, and the tool we use to measure atmospheric pressure is called a barometer. Barometer. So, the oldest barometers in existence. I'm going to draw this for you. I'm probably going to draw it pretty badly. Do you all know what quicksilver is?
Yes.
What's quicksilver? It's another name for a metal. Mercury. Very good. So, we'll turn off